Hi class, this is Professor Smith. I'm going to be doing a problem on the rational zeros theorem. In this example, we're given the function that has at least one rational zero, and we're going to use this fact to find all the zeros of the function. The theorem says if you take the constant term in our polynomial expression of -5, and we're going to let that be p. And then we're going to take the leading coefficient, which is 6, and we're going to call that q. It turns out that our zeros, or the values of x that will cause g of x to be 0, are of this form. X equal to plus or minus all the factors of 5 over plus or minus all the factors of 6. In interest of time, I'm just going to ignore the plus or minus until the very end, just so that I don't have to write it for each factor. 5 has factors of 1 and 5. 6 has factors of 1 and 6. And 2 and 3, ignoring the sign. Finding the zeros is every possible combination of these factors. So let me give you an example. X could be 1 over 1, 5 over 1. X could also So x could be represented by 1 over 1, 1 over 2, 1 over 3, and 1 over 6. So let's capture those possibilities. 1 over 1, 1 over 2, 1 over 3, and 1 over 6. And simplifying 1 over 1, we could write it as 1, 1/2, 1/3, and 1/6. We could do the same with the 5. So other possible answers would be 5 over 1, 5 over 2, 5 over 3, and 5 over 6. 5 over 1 can be simplified as 5, and then we have 5/2, 5/3, and 5/6. So the rational zeros theorem says if we're going to have a zero, it's going to take on one of these values, plus or minus. So we could have -1 instead of just 1, or -1/2 instead of 1/2, and vice versa. So all our possible roots will look like this. So I'll add another page. Polynomial is 6x cubed, 31, 4, and -5. So x equal to plus or minus 1, 1/2, and that plus or minus is for each one of these roots. 1/3, 1/6, 5, 5 over 2, 5 over 3, and 5 over 6. So what we do is we use synthetic division to determine which one of those are the lucky numbers. So I'm going to start off with 1, just because it's a nice number, and I hope that that will be one that will work. So x equal to 1 will be our first attempt. The coefficients for our bringing down the 6, 1 times 6 is 6. Adding, I get 37. This doesn't look like it's going to work. 37, I add that, I get 41, and there's no way that's going to give me a 5 to get a 0. So x equal to 1 is not going to be a root because I'm not going to get a remainder of 0. In fact, I get a remainder of 36. So since it's not 0, that one doesn't work. So then we try -1. And so -1, again, we keep those same coefficients, 6, 31, 4, and -5. We bring down the 6. -1 times 6 is -6. When we add that, we get 25. negative 25, we get negative 21, and then we get 21. So again, we're not going to have a remainder of 0. So x equal to 1 didn't work, and x equal to negative 1 didn't work. So let's go ahead and try maybe 5. And I'm only picking the whole numbers just because the math is a little bit nicer with the whole numbers. Again, the coefficients were 6, 31, 4. So here are all the possible roots: 1, 1/2, 1/3, 1/6, 5, 5/2, 5/3, and 5/6. And again, plus or minus, so that negative 1/3 would have worked. So let's try 5. And negative 5. Bringing down the 6. 5 times 6 is 30. Hey, I think we should try negative 5. Let's try negative 5. This is just going to get bigger and bigger and bigger. So let's try negative 5. So bringing down the 6, we get 6. Negative 5 times 6 is negative 30. When we add those up, we get 1. Negative 5 times 1 is negative 5. When we add those up, we get positive 1. No, we don't. We get negative 1. Hot dog. Negative 5 times negative 1 is 5, which gives us a remainder of 0. Jackpot! So we know that x equal to negative 5 is a root. So now that we have that x equal to negative 5 is a root, we also know what the solution is when we find the quotient using the synthetic division formula. These are the coefficients of the quotient. And it's 1 power less than the original, which was x cubed. So our quotient is going to be 6x squared plus 1x, which I'll just write as x, minus 1. So now all we have to do is find out what will make this expression 0, and we'll have another root. So we can say, what are factors of negative 6? Because if we take 6 times negative 1, it's negative 6. So what are factors of negative 6 that add up to 1? And looks like 3 and 2 are the lucky winners. And I think if I make the 2 negative, that'll work. So when I multiply 3 times negative 2, I'll get negative 6. And when I add 3 plus negative 2, I'll get 1. So I know that 3 and negative 2 will work. So let's add a page and continue this. I need a 3 and a negative 2. So have 1 and 6, 31, 4, and negative 5. So I have 3x and 2x, because I know I'm going to need a 2. What did we say? So if I put a negative 1 here, a positive 1 here, that'll give me my 3x. And if you put a negative 1 here, that'll give me minus 2x. And when you add them up, you get 1x. And you say, well, Donna, how did you know to put a negative 1 and a 1? Well, when I multiply these two together, negative 1 times 1, the last term in each one of the factors, that gives me the negative 1 up there. And 3x times 2x gives me the 6x squared. So this factors now into 3x minus 1 times the quantity 2x plus 1. Setting each factor equal to 0, we have 3x minus 1 equals 0, or x is equal to 1/3. And then 2x plus 1 equal to 0, we get x equals minus 1/2. So that gives us all our zeros. We got x equal to negative 5, 1/3, and negative 1/2. So notice that 1/3 and negative 1/2 were part of the possible answers that we had when we first wrote out all the possible roots. We done our synthetic division, not negative 1/3, positive 1/3 would have worked. So had we done our synthetic division with 1/3, it would have worked. Right? So if we did 1/3, and then the coefficients I think were 6. So if we brought down the 6, 1/3 times 6, 6 over 3 is 2. When we add that, we get 33. So if we take 33 divided by 3, that's 11. And then 11 and 4 is 15. And if we take 15 divided by 3, that gives us 5. And when you add it up, you get 0. So we see that x equal to 1/3 would have worked as well had we used it for synthetic division. So that concludes our first problem on using the rational zeros theorem. So we got x equal to -1. No, not -1. It was -5. -5, 1/3, and -1/2. I'll pause now or stop now, and I'll make a second one.